Hello and welcome to the second lecture in lesson 1, where we'll quickly introduce the LEAP software that we will be working with for the rest of this course. So let's get started. LEAP is an abbreviation of the Low Emissions Analysis Platform. It was formerly known as the Long Range Energy Alternatives Planning System, but due to a major update this year, it changed the name. The LEAP software is an integrated modeling tool. That means it can do multiple aspects of the energy system analysis. So it can both analyze different forms of demand, supply, transformation, land use change, and electricity supply changes. And you can do that over a number of years, which makes it very useful for our use cases of analyzing a full energy system. The LEAP platform is made by Stockholm Environmental Institute that, despite its name, is actually in Boston, USA. I am not affiliated with them. I am just a user and have been for a number of years. It's a commercial software and it has different licenses for private use, consultants, and also government users. The really cool thing about LEAP is that they work with a differentiated pricing depending on the World Bank country classification, which is a GNI per capita method, meaning it is actually more expensive for richer countries and even free for some third or fourth tier country according to the World Bank classification. Now, benefits of using LEAP. The main benefit of using LEAP, it is a small software model that just runs on any small Windows laptop. You can do complicated models or simple models, but they will all run on very basic buy at the store hardware. It also has a very easy user interface, which is one of the major benefits. It's easy to navigate, it's easy to update when you have gotten into it. After this course is done, you should be fairly comfortable in going in and editing or updating models and even develop them from scratch. It also has some quite small file sizes. That means that instead of having having gigabytes of data, then it will actually just, any full modeling LEAP will be anywhere from 5 to 100 megabytes, which means it can easily fit on a USB sticks. It can easily be stored. It can easily be stored in file software and online. It also does have some methods for collaboration that is quite simple. You don't need to use Git for this. A common office drive is quite enough. It's very easy and very fast to calculate. The most complicated models that I personally worked with takes around 13 minutes to calculate for the base scenario and then lesser time for every inherent scenario, and we will get back to what that means. That also means when you are very quickly updating and calculating, that is very, very quick update cycle. So that means you can do changes, edits, corrections very, very fast when you get new data. It is also very flexible. It has a few methods for analyzing different things. And even within those methods, you can bend and shape them quite easily to what you need and depending on your data source, which is quite a big benefit in terms of how easily it is to get a model out the door. It supports different regional sizes, means you can go from a small sub-region in any given country to multinational. So it can do from anything from a small region in any given country, an island even, to a ASEAN-like size where you divide the model into different regions of different countries, and then finally the full region itself. Of course, this has a effect on calculation and also on the general overview, but it can be done. There's quite a lot of functionality you can turn on and off without it deleting it, meaning you can, if you are in a track where you do quite a lot of updates on the demand side, you can actually choose to take your cost on and off, your transformation and resource side on and off that otherwise also would calculate without them being deleted in any way. And that means you can update and make sure that your demand side works before you involve the other sides. Again, we need to update it for this year, or in a scenario where you are doing quite a lot of corrections, this is a very big benefit as well. So yeah, the main things are it's easy to run on small software and it's very quick and adaptable. It should also be mentioned that it has quite a special scenario structure. That means that it's very easy to work with both a small number of big scenarios, but also a large number of scenarios. It does also affect calculation time. Again, it's quite small. And then, full transparency, I personally think that Leap is very cheap. Energy modeling software have a tendency to cost in the hundreds of thousands even of US dollars, but Leap has a very fair software price that comes with a license, that comes with all the new updates and everything. And again, depending on the country richness overall, that actually gets shaped as well. So it is a pretty preferred pricing for any country, I think. A big side benefit to Leap is that they also have a pretty vibrant online community on their website. And as you can see here on the slide, in their main website, just go to the discuss if you have a login, and you could go into the Leap support. And usually, whatever question you have, whatever problem you have, there will be someone else who had the same problem. And even the people at SCI in the US is also quite active in there to have support. So this is the main support place for Leap. It's very recommendable. There's quite a lot of posts from me as well. Disadvantages to Leap. It only runs on Windows, so if you have a Linux or if you have a Mac, it does not work. Of course, both of those you can have Windows in as well, but unfortunately not on these platforms. It does also mean you have to have a license for Windows to even begin running Leap. It is very much just a good office software kind of thing. That also means the fact that it runs on desktop Windows also means like even if you have very powerful server level hardware, that doesn't mean much to Leap. It will probably make calculation runs quicker, but not anything special. On the other hand, most Leap models run calculates within 10 minutes, so it doesn't really mean much. There is some functionality that is missing. They are working on updates all the time, and I hear from the summer of 2020, they will soon add, or have just added functionality to have battery storage and general storage, large-scale storage, better represented. Other disadvantages, again, it has costs. It might be cheap, but it does cost money. Some models are free, this is not. In terms of training, it is quite limited in terms of getting official training. It's a small team, and it usually involves some travels. We have also done training, and of course this will hopefully be online afterwards, so there will be some more online training. There is a lack of depth of special sectors, especially in terms of power. To forecast the electricity supply sector, usually you would want a big optimization model that can maybe even have something like load flow involved, and Leap does not support this. However, these models are very expensive and very big and cannot be run on even desktop hardware. So that is a server side mostly thing. In the DA, we also have Bamra that does some of these things. Otherwise, energy security, for power, there is Sisyphus, which is also desktop software. And then for low flow, there is a commercial software from Siemens called PSSE. And Leap does play somewhat well with all of them. We will get back to the relationship between Leap and Bamra later on, because we have done that in the DA specifically. So that will come in lesson 4. This image is of the basic structure in Leap. And as you can see, in the middle of it, or rather as a core of it, we have the demand analysis. This demand analysis is always present in LEAP, and you cannot avoid it. It is where the starting point is. This is where you define the different sectors of demand, like industrial demand, transport, housing, etc. And it is also where we will be spending far the most of the time in this course, because we will use that as where we learn about the basics of inputting and resulting in LEAP. This is always present, you cannot take this on off. Then the next important factor or branch of LEAP, that is the transformation analysis. In the transformation analysis, it goes from, for instance, primary fuels like coal and oil and other sources, or secondary fuel like gasolines, to electricity. That's where this gets calculated. So it has the power supply sector, for instance, if you have that in LEAP. It also goes from the primary fuels to the secondary fuels. So that is the transformation module for going from crude oil, for instance, to gasoline and diesel, or from coal to coke, different other things, biomass to biofuels. Then the next one is the resource analysis. This is where you keep tax on the resources that are available in your country, import and exports. So in these resources, both for primary and secondary fuels, we can see how much capacity for coal do we have in the country, how many reserves, how much mining do we have, what are the reserves for our oil extraction, and also how much biomass do we have in the country. It also, which is not represented here, it also contains a land use change where you can quite easily analyze the changes from forestry to energy crops and from the yield of energy crops per year. So you can keep a good idea of how much of your biomass you're using. This is also good for LULUCF, which is the use of energy crops and their CO2 emissions and CO2 reductions analysis. This is a very good for that. The rest of these, generally speaking, I would consider as being more of a tag on, tag off branches. Statistical differences between demand and transformation, that is just corrections compared to statistics, which is very useful to have, but we don't use it that often. We will not be using much of it here. I can maybe make some extra video on that, but it's not part of the general course. The same thing with stock changes. That is also dependent on what you have your official input and how much that changes your stock. I have never personally used this, and we will not be coding that much in the course. Then you can also tag on the emissions from your non-energy consuming sectors. Again, LEAP is about energy, but it's not only the energy consuming and producing sectors in a country that might produce emissions. Something like manual agriculture, forest burning, other things you could put in here as well. And then we also have a pollutant emissions. You can calculate pollutions both in terms of CO2, but also in terms of PM and all other pollutants that you want to check on. We will be covering this in the course. Then in the end of the course, we'll also look at the integrated cost benefit analysis, which is all about the health impacts and cost impacts of using different forms of energy and pollutants. In terms of the demographics and macroeconomics, this is key assumptions. There's a specific place for this in LEAP. We will be using quite a lot because it is very good for overall macro input, not just in terms of economics, but also in terms of big macro scale developments like population, which is demographics cost, but also in terms of the GDP, GNI, which is the macroeconomics, but also maybe you want to put that a place for transport, the total sales forecast of cars and the total transport kilometers expected per capita and these things. And then, of course, in environmental externalities, that is something that lies between that is a result you can get from inputting the environmental loadings, and you can get the externalities in a non-cost and cost basis. Quite smart. This is what we had for the second lesson or the second video in lesson 1.